Okay. Let's continue with the implementation of the card. So in Java we have the constructor that will receive the create message. The create message is quite UML specific because all languages do not have this notion. So, all right. We have one small thing to think about here. We have the color and value arguments. But what should they be? What type should they be? Well, we could go for string, string. Is that a good choice? Value could be an integer, of course. But in the chat here online we get another suggestion, and that is to use enumerations. And that is probably the best choice, because we have a fixed number of colors and a fixed number of values that a playing card actually can have. So we have 4 types of color, and we have like 13? Is it 13 types of values that we can use? So using a string for the color, well, that seems to be kind of like error prone, because we need to store kind of like these strings somewhere, and it will be easy to make a mistake, just spelling mistake, or should we have the first letter as a big letter or as a small letter? Well, a lot of stuff that we need to design, and maybe also add some error handling here if we sent in something in color that is not allowed. So, and we can get this automatically by using enumerations instead. So I think that is a good idea. And I'm cheating a little bit because I have them already. And here we have those enumerations. So I will just copy them and paste them. So, good. So we create an enumeration for the color: hearts, spades, diamonds, clubs. Also, I have actually added a count. That is something that I usually do. Some languages have the ability to treat the enumerations as objects and classes that you can manipulate in different kinds of way. Some languages do not. I'm basically a C++ programmer, and in C++ enumerations are more or less handled as integers. So having this count here will help us a little bit later on. So, okay, color, value, and we need some way to store this and to have the responsibility of storing the color and value, and it won't be any more strange than adding some arguments here, attributes I mean. Color, and if you remember also, taking a look at the domain model, it was obvious that these should be put inside the card class here. So if we take a look at the domain model, we find value and color there also. So we should stick to this if we can in the design. Thank you. So maybe something like that will be it for this card class for now at least. So let's try to compile it. And it worked. That was good. So we can move on, and maybe the next step is to take a look at the deck. So let's take a look at the class diagram here maybe again. And we can see that, well, we need some way to implement this relationship. It should contain some cards, and it should be named m_cards. And, well, seems to be no real specification on what to do there, so let's just use some kind of a collection class, and I think I will just use a linked list. Let's compile. That seemed to work at least. So the next step is to take a look at the sequence diagram. And what should happen in here? Well, we should create a bunch of cards. We should do some looping for every color and value. And we should create the cards, and we should add the cards also. So let's do that. I need to check this up. So we use this count enumeration to get the number of cards, colors inside the card, and iterate over that. And we should use the these indices to create the card, so that we get one card for each color and for each value. And we should add these cards, of course. So we need to implement add also. All right, compile. No return type. So that also seemed to work. Next step, dealer. So, and we can take a look at the sequence diagram. to know what we should do. So in the dealer constructor, we should create the deck, and later on we should shuffle the deck. And in the class diagram, we can see that, well, this should be using the association that we have named m_deck. So that also needs to be implemented. So that would be it, and I think we need to add a shuffle here also. And we will just leave it as empty for now. Compile, shuffle as private access. So something like that. And maybe just to test drive things, we need to maybe add a small program class here, I think. And of course nothing happens because we don't actually output anything. So yes, let's just add some simple output to test stuff. Maybe we could add something here. And we know at least that we get something. A number of cards are created and added. So it would be interesting to know now that if we get something like So we now get a little bit more information from our quick and dirty printout. So we have the hearts, 2, 3, 4, 5, 6, 7, 8, 9, 10, knight, queen, king, ace, and we have spades, and we have diamonds, and we have clubs. So small quick and dirty testing seems to be working. Our creation is at least done here. So next thing is actually to implement this shuffle operation. And there are probably a number of ways to do this. Basically, what I will be doing is just to pick a random card from the deck, remove it from the deck, and then add it to the deck. So kind of like pick one card, add it on top. Pick one card, add it on top. And I think we have. So basically, we pick a random card from the deck, and we remove it from the deck, and then we add it to the deck again. And we do this a number of times, and well, maybe the cards then should be sorted, randomly sorted, or if you can say that. Let's run. Okay. So we seem to be getting some kind of random sorting here. Remember that we do this 1017 times, so add will be called a number of times, but this is the first random card that's picked, and it's put on top, and then this is the second one that is picked, and well, it seems to be pretty random. Of course, it's not perfect randomization, so I think we will suffice for our needs at least. So that seems to be working too. And of course, adding kind of like this is not a good thing. It breaks our architecture. We're really not supposed to do that. So if we do it for testing purposes, as we did, we need to make sure we remove it later, so it does not linger on in the code. And well, maybe some other developer sees this and he thinks that, oh, okay, this is okay to do. So he adds his printouts or debug stuff, and some other programmers come along and see that, okay, this is the norm to do print stuff, is to add this type of printout inside the model. And slowly but surely our architecture kind of like erodes. So if we run this now, we should not get kind of like anything. Oop, nothing. Okay. One interesting thing to think about is maybe this shuffle operation. When doing the sequence diagram, I actually did not spend so much time on it. It's quite internal. It actually calls add. So maybe that should be added to the sequence diagram. We could also add more information to the sequence diagram now that we know a little bit more about the relationships here. We know that this object that we create, it's actually called m_deck. So adding this information could be good. Also, this would be a tight fit, but and look at this. So something like that we could do to update our sequence diagram. But moving on to the shuffle operation. Thinking about stuff, how it works in real life, and that is always something that you should maybe have in mind. We don't have a lot of self-shuffling decks. But actually it is the dealer that picks a card randomly from the deck and puts it on top. Picks, puts on top. Picks, puts on top. So why did we add this operation inside a shuffle? Why did we add shuffle to this? Why is it not the dealer's responsibility to shuffle? This is something that is happening in real life. So maybe we should have this in dealer instead. Just to do this loop and get a random card. So we add public card, get random card. And it will kind of like be this. Let's just comment that one out for now. And we add the, so we do something like this instead. Instead of calling shuffle, well, the dealer uses the deck to get the random card and add something like that instead, maybe. And I think we also need to make this public. So, this should work in exactly the same way. We should get the same kind of random shuffling of the cards, and it mimics maybe reality a little bit more. So, which one is better? Same functionality. Two different ways of doing this. Should we do it like this, or should we keep the shuffle operation inside the dealer and deck are more intangible, so to speak. Okay, okay. Oh, yeah. I could agree, and we have actually one in the chat here that we can actually see this. If we look at the implementation, suddenly we have this. This would mean that we have a dependency now from dealer to card. So then we need to add this dependency in our class diagram. So we get another type of relationship here between dealer and card. And adding a relationship that is actually not needed, well, that could be a bad idea. So that's definitely one more coupling that is unnecessary, at least right now. However, I could argue that, well, the dealer will probably be dependent on the card class eventually anyway. Well, he will need to give cards to the player, remove cards from the deck, give to player, etc., etc. So, while we can avoid this coupling right now, I don't think we can do so for very long at least. But it's indeed an argument that we add a coupling by doing the random shuffling inside the dealer instead. So we have like one pro and one con now. We have mimic reality, that is pro using the dealer to do this, but this adds a little bit more complexity and a coupling inside the dealer. So, anything else? Well, the responsibility to shuffle it actually don't exist as a function at least anymore. And that could be if someone says to you, well, we have the cards are not randomly sorted, there must be some problem in the shuffling of the deck responsibility. You don't really know where to look. There is no shuffle operation anywhere anymore. So that is indeed a bad thing. And this mapping from requirements, I think it's even said in the requirements that they are randomly shuffled, and shuffles them. It seems like having a shuffle operation then somewhere would be a good thing. On the other side, we could add inside the dealer, we could do this like a operation instead. That's called shuffle, and add it here. So we could find it. So that would kind of like remedy that issue. All right, I think we could kind of like argue about this for a while, but let's take a look at the grasp patterns and see what they say, because we could use them as our guideline. The first pattern we have is information expert. And as you remember, a pattern is an abstract problem, an abstract solution, and it has a name. The name in this case is information expert. And the problem is, what class should get a specific responsibility of knowing or doing something? And the abstract solution is to assign the responsibility to the class that has the information needed. So, we should think about what information is needed to fulfill the responsibility of shuffling, and do we have someone that already knows about this in the implementation or design? So the information needed, in this case, well, we are supposed to shuffle the deck, so we need access to the deck in some way. Do we have someone in the implementation that has access to the deck already? Yes, we have. We have the dealer. And what more information is needed? We need information about the cards, because we are getting a random card and we are putting the random card back. Do we have anyone that has information about the cards already? The deck. And the deck also knows about itself, so in this case, the deck should be the information expert. The deck class has the information already available. So the information expert pattern points us to actually not do this, but let the deck be self-shuffling, even though that it may be counterintuitive from a reality standpoint. Let's do this also. We should put the responsibility, give the responsibility to the class that has the information needed. And mostly we need to know about the cards. We need to know about the cards that are inside the deck. And the deck class is the one that has this information already. So moving this information out to someone else, well, it breaks encapsulations and stuff like that. However, I maybe will keep this, because I think that was maybe a good idea to have this random card. And you can also see that I had to open up this class also a little bit. I had to change these operation add from private to public. I had to add this as a public operation. So opening up classes for others to get access to the information that is supposed to be internal, it's probably not a good idea. And by using information expert as a guideline, we can make sure that things are kept as encapsulated as possible. So something like that, maybe. So this get random card function, I think it's probably a good idea. And you could also see this in the code. This is something that you sometimes can spot that, well, the only thing that we're doing right here is where we're getting something from someone else, we're doing something with that something else, and then we're putting it back into the same object again. Sometimes you see this in the code that you loop over some collection of stuff, and you just do something with the objects that you get, and then you put it back in the collection, or they're not removed from the collection at all. And then you should ask yourself, well, should not this be the responsibility of the collection instead? So always when you have kind of like this, I loop over a bunch of objects and do something with them and put them back, or just leave them as they are, it should prompt you at least to ask yourself, should this responsibility be put inside this collection class instead? So let's just remove that. So I think we are good to go. Yeah. Back to the patterns. So, information expert, basic principle of responsibility assignment. Try to find out what information is needed to fulfill this responsibility. Take a look at your current design and/or implementation, and find the place to add it by looking for the information that exists. Sometimes it's not as easy as we had it now, just knowing that, okay, we need access to cards and we need to know about the deck. Sometimes you have information that is spread out. Some class knows something, some other knows something. Then you need to find someone that knows about both, and you can add the responsibility there instead. It's not always easy to know, especially if you do design first, exactly how this is going to be implemented and what information is actually needed in this implementation. We can also have other types of requirements or forces that tells us to not do certain things. For example, oh, I need to print the card to the console. Who has the information needed? Well, the card has the color and value needed. So I should add a print operation inside the card class. However, this would probably break our architecture if we have the model view separation principle to force us into splitting these kinds of responsibilities. So you need to think a little bit about that stuff also. But as a basic pattern of responsibility assignment, I think this is something you can always go back and think about. If you are really confused and the code looks strange in some ways, it looks overcomplicated and stuff like that, think about the information expert and move responsibilities to the class that has the information that is needed. Sometimes this also means that you need to divide your function maybe into different sets of functions instead of having one big large one. And that is often a good thing. The next pattern that we have actually used is creator. And creator is about creating objects, and that was kind of like the first requirement that we had. We need to create the deck and create the cards. So creator handles these types of problems. The basic problem of who should create objects of another type. And we have 4 cases to think about, and we should assign the responsibility to create objects of type A to class B if B objects contains A objects. And this was maybe the case of the deck and the cards. Well, the cards are contained inside the deck, so the deck should be responsible for creating the cards. We could, of course, create the cards in the dealer or somewhere else and send them into the deck in some way, but this would again need us to open up the deck class, make the add operation public, and, well, that's not a good idea probably. So, by knowing that the deck contained the cards, it was natural also that the deck created the cards. The second rule is to know that, well, B objects have the information needed to create A objects. This was actually a little bit the case in the card creation also, because we could not just create cards at random. We needed a combination of every color and value, but not any duplications. So we needed to know what cards we had already put inside the deck. And the deck, well, it has knowledge about the cards that are inside of it. So it is kind of like also the information expert in this sense. And the second rule here is, well, it is something like the information expert, but related to object creation. So if you have some type that has the information that is needed to create the objects, well, maybe that class should be responsible for that. We also have two a little bit more hard to judge cases here. B objects records A objects, and B objects closely use A objects. I don't think we have any case of this right now, but for example, in our dice game, it was natural that the dice game created the dices that we needed, because it was the class that used the dices when we played. So it kind of like closely used the A objects.